Hello students, welcome to JEE English, a new channel by Unacademy, the India's leading IIT JEE preparation platform. Guys, in this channel we are going to deliver content exclusively in English, and for you guys, if you're preparing for IIT JEE and other engineering entrance exams, this is the platform for you. Subscribe to our JEE English channel. And today we are going to learn about A to Z of projectile motion. I'm going to cover from the basics until the depth of projectile motion. I'm going to cover every nook and corner of projectile motion and every bit and pieces of projectile motion, guys. It's a really easy topic. All you need to do is you need to stay along with me and you'll understand this projectile motion in no time. And guys, let me introduce myself to you. I am Murlidharan. I completed my MS in Electrical Engineering from University of Colorado and BTech from IIT. I have 4+ years experience preparing students for IIT JEE and etc. And guys, more importantly, I am very passionate about physics, guys, and I want to make sure that you also become passionate about physics. You understand, every fundamentals of physics. And guys, we have something very interesting for you. That's our Unacademy learning app. You can download this app from the App Store or Google Play, and you know what? You'll get free live classes on this Unacademy learning app. We have special classes where we give you, every much insight like how we give on our channel. And guys, if you're preparing for IIT JEE and we have something more interesting for you, that's our premium platform where you can subscribe to our platform. You can purchase our subscription. You'll get structured learning. You'll get video books. You'll get, test series, guys, test series. I know it is very important for exam preparation and it's a nice choice for, test series. And guys, get this subscription, and if you're looking for some coupon, you can make use of this Murli Live and you'll get 10% discount on your purchase. And guys, if you're in 10th class and if you're preparing for IIT JEE 10th or 9th class, I think this 24-month subscription goes well, and it only costs 1,500 per month. Guys, it's a very reasonable package. And if you're on a long term or you're a dropout, I think this 12-month subscription is also very good, which is only 2,500 per month. And right now we are on a lockdown. If you're planning for preparing for 1 or 3 months, then you can opt out for these options. Guys, it's a really great platform for learning. It has the best-in-class content from the best-in-class educators, IITians and etc. from people like this. And even we have DC Pandey, on this platform. And guys, let's get started on the topic of the day, projectile motion. So you see this, footballer kicking this ball and it's traveling in a nice curvy linear-like path. And this curvy linear-like path is called projectile trajectory, and this motion is called projectile motion. So just before we get started with the projectile motion, we will revise some, basics of position vector. So in projectile motion, we are going to always resolve things. So that is why we are going through this topic. Alright guys, what's a position vector? A position vector actually tells me about the position of a point object or an object in a reference plane. So let's say I am at this point and I'm, saying that, hey, let's meet over here. And I'm telling you just that I'm 5 units away from you. But would you be able to make it out how you're going to reach me? No, right? Let's say you're at the origin. So how are you going to make out? If I say 5 units, there can be 5 units along x-axis. There can be 5 units somewhere over here. There are infinite such 5 units points. And you may never be able to meet us because it is, 5 units tells you nothing. It just talks about the distance. You need to know the direction. So what if I told you, hey, I'm standing, 3 units away from x-axis and 4 units away from y-axis? It becomes easy. I'm telling you the exact position. So when I've told you I'm 3 units away from x-axis and 4 units away from y-axis, all you need to do is you need to move 4 units along x-axis and 3 units along y-axis or parallel to y-axis to reach this point. So that's the significance of a position vector. So you see in this case, this R, position vector R, as a magnitude 5, but the magnitude does not tell you everything. This 4i cap plus 3j cap tells you the exact position of this point object. So now let's say I'm saying, hey, let's meet, and I'm moving at 1 meters per second. So now again, it's a confusing thing, right? I'm over here, I'm saying that let's meet, I'm moving at 1 meters per second. But how is my position changing? Is it changing along x-axis, y-axis, or at some angle? But what if I have told you I am moving 1 meters per second parallel to x-axis? That gives you, better information about the change in position. That gives you the definite position where I am. So a velocity vector is one where it defines the direction of the movement of this position vector or this object's position. So velocity vector has both the direction and keeps you telling you constantly about the change in position of this object with respect to time. Okay guys, and it is important that you resolve this vector so that you better understand it, how far you have to travel along x-axis with respect to time and how far you have to travel along y-axis with respect to time. And similarly, let's say I'm telling you that, I am moving at 1 meters per second square. That is like I'm accelerating at 1 meters per second square. It would become like a chicken and egg problem. You would never be able to find out that because it is also varying with respect to time twice. I mean like the position d square by dt square, d square r by dt square, which means it is very tough to find out. But if you resolve this acceleration vector, it becomes easy, right? Like if I'm telling you like I'm moving 1 meter per second square, that means my velocity is changing 1 meters per second square with respect to time. And if I exactly told you I'm moving 1 meters per second square parallel to x-axis, that means that my position vector and the velocity vector are changing exactly at what quantity with respect to time. So guys, if I told you 1 meters per second square along y-axis or parallel to y-axis, that means my velocity is changing 1 meter per second every second. So basically what's an acceleration vector then? Acceleration vector is nothing but change in velocity vector with time. So position vector tells you the exact position of an object in a reference plane, and a velocity vector tells you how this object is moving with respect to time. Okay, and a velocity vector also tells you the direction of this movement of this object, and the acceleration vector tells you about change in velocity vector. So an acceleration vector talks about change in velocity vector with respect to time. So guys, if you know all these three, you will be able to exactly determine the position in a kinematics motion. And it is important that you resolve it for calculating it for any of the 2D motion. So a 2D motion is no different than a 1D motion, where you are going to solve this equation in 2 dimensions or along 2 axes. But first let's understand what is a straight line motion or a rectilinear motion. A straight line motion has a position vector changing only in one direction, or this velocity vector with respect to time changing in only one direction. So you see this curve over here in straight line motion. At 5th second it is at some point x1, at 10th second it is at point x2, and at 15th second it is at point x3. It has been moving along x-axis, but what about y-axis? It is constant along y-axis. So this is a straight line motion, isn't it? It has a direction, but this direction is only along one axis. You can define it using only one of the axes, and it's a straight line motion, which means it satisfies this y is equal to mx equation. So a straight line motion has a changing position vector along only one direction, and this velocity vector is also changing along only one direction with respect to time. And guys, another crucial thing. So let's say I've rotated this axis, I've changed the reference frame, and now let's say this axis at an angle theta. So what happens now? Is this object really moving in multiple directions along x and y axis? Of course, if your reference plane is this, it is probably moving in both x and y coordinate, but it is still moving in the straight line. It's a straight line motion or a rectilinear motion which satisfies this equation y is equal to mx. So a straight line motion always has one direction that can be defined by joining all the different positions in time with a straight line. So that's a straight line motion, guys. So when we talked about straight line motion, you must have understood the next thing we are going to talk about is a 2D motion. So we are going to talk about a 2D nonlinear motion. So what's a 2D nonlinear motion? In a 2D nonlinear motion, the object is changing both in x and y axis with respect to time. So you see this object over here, at 5th second it is at a different x and y, at 10th second it is at a different x and y, and at 15th second it is at a different x and y. In a 2D nonlinear motion, it has a changing velocity which is moving along both x and y axis. I mean, the velocity is changing along both x and y axis, and the position is also changing in both x and y axis. So the specialty of 2D motion or a 2D nonlinear motion is you cannot use a single line to track its path. I mean, a single straight line to track its path. See, over here, I cannot use a single straight line. I need multiple straight lines, because it's changing time in both x and y axis. Even if you rotate this reference frame, still don't you see that? You can't, make it out in a single coordinates, like in a single line or, using a straight line. It's still changing in both x and y axis. So that's a 2D nonlinear motion. And this projectile motion is a kind of 2D nonlinear motion. A projectile motion has some assumptions. One is that it is only working under the acceleration of gravity or the influence of gravity. So the definition of projectile motion says that an object is projected near Earth's surface at a certain angle, and this motion occurs in a curved path only under the influence of gravity. And this is a curvilinear motion. You see this object over here? It is in a curved path. It's a curvilinear motion, and the gravity is the only constant acceleration or deceleration acting on it. That means this gravity is acting along the y-axis, negative y-axis, and the velocity along the x-axis is not changing in a projectile motion. We'll understand it in more depth when we use, all this Newton's equation of motion and solve it. And it is crucial for you to understand that a projectile motion is like, a motion experienced by a body projected at a certain angle only under the influence of gravity. And this projectile motion makes a curvilinear like parabolic path. Okay. And it's a curved path, guys. And when you look at from the x-axis point of view, it looks something like this. With time, it is changing all along the x-axis. So at 0th second, it is at some point x1. At 5th second, it is at some point x2. And at 10th second, it is at some point x3. And similarly, even it's changing along the y-axis. At 0th point, it is at 0th second, it is at point y1. And at 5th second, it is at point y2. And at the 10th second, it is at point y3. Which means, in a projectile motion, the object is moving along both x and y axis with respect to time. So, this object is moving along both x and y axis. The coordinates are continuously changing with respect to x and y axis with respect to time. And it's a curvilinear motion. That is projectile motion. It is as simple as that. So guys, have you ever noticed this projectile motion in real life? Absolutely, you're seeing it every day. You're seeing something very similar every day. So you must have played, like football, and you must have kicked this football, and you must have noticed that it moves in a nice curvilinear like path. That's a projectile like motion, or it's a projectile trajectory. Have you ever noticed this fish or a whale jumping out of the sea and making a projectile like motion? And these fishes also make something like a projectile motion. You must have gone to parks and you must have seen this fountain in a projectile like trajectory. So you're seeing this projectile motion, of course, in your everyday, or this projectile trajectory, of course, in your everyday. And in fact, you can make use of this in your real life, especially in sports. You know what? You can make use of this projectile motion to improve yourself if you're in a sports, or if you're in, in a sports team, something like football, shot put, discus throw, whatever be it, there is a projectile motion. You can apply this projectile motion in your real life and improve things. So that's the beauty of physics and projectile motion, guys. You can apply them in your real life. And guys, so what's this projectile motion? Let's understand it from, equation point of view, and how does it look in a 2D, how does it look in a plane? It's a 2D motion, right? So how do we solve this? So there are some assumptions in projectile motion. One is the gravity is the only acceleration acting on it, and it is projected with an initial velocity u and launched at an angle theta. So in a projectile motion, you are launching it at an angle theta with an initial velocity u. And gravity is the only acceleration acting on it, that too in the negative y direction. And the velocity along x-axis is never influenced. So what do? You would have to resolve this velocity vector. So this is the angle theta with x-axis. That is how I projected this object in this projectile motion under the influence of gravity. And what happens is, I'm going to resolve this vector along x-axis, which is going to be ux is equal to u cos theta, along the y-axis, which is going to be uy is equal to u sin theta. So uy is equal to u sin theta and ux is equal to u cos theta, given that the theta angle is formed by this object or this, this motion with x-axis. Okay guys, I guess this is clear. This is very important. And now we'll see something very much more interesting, that is this projectile trajectory. So what's this projectile trajectory? A projectile trajectory is nothing but this path of this object in projectile motion. So when this object is moving in this projectile motion, it's forming a path, right? If you trace this object, there is a path. This path is called projectile trajectory. And you notice this thing about projectile trajectory? It has different x and y coordinates. And the object is also moving with different x and y coordinate with respect to time. And this motion is called projectile motion and this path is called projectile trajectory. And guys, this projectile trajectory is in the form of parabola. It's generally in the form of parabola and this projectile motion has a parabolic path. So let's derive this equation for this projectile trajectory and see whether it's really a parabola or not. But before that, we'll get into Newton's equations of motion to understand how to solve this projectile trajectory. So these are the three fundamental Newton's equation of motion or three Newton's equation of motion. So the first one says v is equal to u plus at, which is nothing but final velocity is equal to initial velocity plus of acceleration times time. Okay. Initial velocity final velocity v is equal to initial velocity plus acceleration into time. That's the first equation. The second equation is s is equal to ut plus half at square, which says that displacement is equal to product of initial velocity times time plus half at square. And the third equation of motion is v square is equal to u square plus 2as, which says that final velocity square is equal to initial velocity square plus 2 times acceleration times displacement. So now what we are going to do? We are going to resolve the components. We are going to apply it along the x-axis and y-axis. So what will be it for the x-axis? No acceleration along the x-axis, right? So Vx is equal to ux. So from the first equation and the third equation, we'll understand that the final velocity is going to be equal to initial velocity, be it in terms of magnitude or direction, because there's no force acting on it. And the next one is Sx is equal to uxt, which says that displacement along x-axis is equal to ux times time. And along y-axis, it's going to be Vy is equal to uy minus gt. So the first equation of motion is going to be Vy is equal to uy minus gt. We have substituted the acceleration as minus g. And the second Newton's equation of motion along y-axis is going to be Sy is equal to uyt minus half gt square. What does this say? Again, my acceleration is minus g. That's correct. And the third one is Vy square is equal to uy square minus 2gs, which says that final velocity squared along y direction is equal to initial velocity squared along y direction minus 2gsy, where sy is displacement along y-axis, guys. Sy is displacement along y-axis and Sx was displacement along x-axis. Okay, and acceleration is minus g. You need to remember the sign conventions while resolving this vectors, while solving for projectile motion. That's when you get the accurate answers. That's when you get the answers. Alright guys, now we'll solve the equation for the projectile trajectory. So now what I'm going to do is, I'm going to replace something in this projectile equation along y-axis using this projectile equation along x-axis to find this projectile trajectory. So I know that Sy is equal to uyt minus half gt square, and I also know this Sx is equal to ux into t, which is nothing but t is equal to Sx by ux. I'm going to substitute this thing as the time. And then you'll find out that Sy is equal to Uy into Sx by Ux minus half G into Sx by Ux whole square. It's in the form of parabola, right? It's like a parabola equation. That's correct. Now what we'll do is we'll substitute this Sy as y and Sx as x. So when we do that, you get more clarity. It looks like, parabolic equation. And now what we'll do further is we'll substitute Uy is equal to U sin theta and Ux is equal to U cos theta. And when you do that, you're going to replace that Uy is equal to U sin theta and Ux is equal to U cos theta. U will be cancelled out and there will be only tan theta. And similarly here you will be replacing Ux is equal to U cos theta. And you'll find out that the equation of projectile trajectory is nothing but y is equal to tan theta into x minus g by 2u squared cos squared theta into x squared, where x is the x coordinate and y is the y coordinate, and tan theta is the slope or the angle, theta is the slope with which we projected this object. And guys, it is again, you can see that it is in the form of parabola. X minus a square is equal to 4c into y minus b. So you understood that a projectile trajectory is like a parabolic equation. That's correct. And a projectile motion travels in a parabolic path, a curved parabolic path. And there are few things, few kinematic properties that we analyze in projectile motion or that we try to find out in projectile motion. And one would be the maximum height. So what's the maximum height? So let's say I projected this object from here and it goes until certain height. What happens is the gravity is the only deceleration acting on it, or this acceleration acting in negative y direction. I projected it in this angle. It has certain y like velocity along y-axis, which is in the positive y direction. But it will lose all of this momentum as and when it keeps going up. Like it will slowly lose this momentum and lose the entire momentum at this maximum height point. So at maximum height point, what happens is this object travels this entire path, like this half of this path in an ideal projectile motion, and at the maximum height it will lose all of this momentum along y-axis. That is, the velocity at maximum height will become 0. That's why it's a maximum height, right? It reaches that height, it comes back. If there was more of this momentum along y-axis, it would have traveled a greater height. So, but it did not have that momentum. The entire momentum was drained by gravity and it came down. So that's what happens. And this particular point is where we calculate this maximum height, the height where this object loses all its momentum along y-axis. So how do we do that? How do we calculate the maximum height? What we'll do is we'll simply use the third Newton's equation of motion along y-axis, where I know that along y-axis the velocity has become 0. And we know the initial velocity, that is nothing but u sin theta. U is equal to u sin theta. And what we need to find out? The displacement or the distance or displacement along y-axis. So by doing that, when we substitute the final velocity v is equal to 0 along y-axis, we get that h max is equal to uy square by 2g, which is nothing but u square sine square theta by 2g. So guys, how do you derive maximum height? You find that point where the y velocity becomes 0. The velocity along y-axis or the velocity in the direction of y-axis becomes 0, tells you the maximum height that the object has attained in a projectile motion. So the next thing is time of flight. The next kinematic property that we are going to analyze is time of flight. So what is time of flight? So the time of flight is this entire time that the object is in projectile motion. Let's say I have projected it from a level plane and it completes this, entire projectile motion. It reaches this maximum height and comes down back to the same, level plane. That entire time of flight is called time of flight. So the total time that the object takes to complete this projectile motion is called time of flight. So how do we do this? So there's a trick to do this. So I'm projecting it from, this plane and it reaches this maximum height and it comes back down. But what happens in this maximum height? So this velocity becomes 0, and again when it reaches this point, the velocity of in the y-axis direction, that is at least the magnitude of the velocity in the y-axis direction is going to become equal. So the velocity of this object along y-axis direction or in this y-axis is going to be equal to this velocity over here. I mean the magnitude, not the direction. The direction is in the reverse direction, right? I mean it's in the reverse. You see this velocity over here, it's like this initially, and over here it will be like this. But the magnitude of velocity is same. So what is this telling you? This is telling you nothing but the velocity, the time it takes to fly from here until the maximum height, that is from the origin or from the place where you projected till the maximum height, is same as the time it takes to fly from the maximum height to the same level plane. Okay guys? So this is how we are going to calculate it. So we will be making use of this Newton's equation of motion, V is equal to U plus AT. And when we do this, we will find out this point where the y-axis, velocity along y-axis is 0, and we'll come to know that, the time of flight or the time that it has taken to travel till this maximum height. And we'll multiply it by 2, since we know that the time it takes to fly from the point where you projected it until the maximum height and from the maximum height to that level plane is the same. So you will multiply it by 2. So initially you will get that the half time of flight is nothing but u sine theta by g, and you will multiply it into 2 to find out the total time of flight. You can also work around the other way where you know that u is equal to u sine theta at the level plane when it reaches from maximum height to that level plane. And you can calculate it that way, but you're still going to get the same result. And next thing we are going to learn about is the range. So what's the range, guys? Range is nothing but the horizontal distance traversed by this object in projectile motion. It is only this distance along x-axis. The total horizontal distance covered by the object in projectile motion is called the range. How do we calculate this range? So there is, this thing where, this velocity along x-axis is never changing. You have already derived the time of flight. You simply multiply that. You know the distance now. You know the displacement along x-axis. So that's what we are going to do. So what we have done for the range, we have multiplied the velocity along x-axis into the time of flight, which is nothing but ux into 2uy by g. Ux into 2uy by g. That's correct, right? And you can also do it the other way around, where you can make use of this Newton's equation of motion and substitute, the relevant parameters to get the answer. And finally, you can work around some trigonometry and you'll come to know that it is nothing but u square sine 2 theta by g. Basically, ux is u cos theta, uy is u sine theta. That is nothing but 2 cos theta sin theta is sin 2 theta, and that is nothing but u square sin 2 theta by g. Let me correct it again. It is nothing but u square sin 2 theta by g. But what is more critical is you need to remember this point, that velocity along x-axis is not changing. Once you have the time of flight, you know the range, because you have resolved the component along x-axis. You are going to multiply it with the time of flight. So what is the range? Range is the total horizontal displacement traversed by this body in the projectile motion. What is maximum height? Maximum height is the point where it loses all of this momentum along y-axis. Is the maximum height attained by this object. Once you project this object with positive y direction, positive y velocity at certain point of time, this velocity is going to become 0 along y-axis. And what is time of flight? Time of flight is this total time that this object in projectile motion takes to complete the flight. It's basically the total time of flight. The total time where this object is in the flight. Alright guys, there's a very interesting thing about range. And we are going to derive this. So you know that sine phi is equal to sine 180 minus phi. So what I'm going to do is I'm going to take phi is equal to 2 theta. And I would do the same thing over here. I would just work the same thing over here and see that, I'm going to put an 180 minus 2 theta. what would happen when I do 180 minus 2 theta? If I do 180 minus 2 theta instead of 2 theta, that is same. The value of range is going to be same, right? And you take this 2 common and you get that it is nothing but 90 minus theta. Correct? Isn't it? So what does this tell you? So for two complementary angles, or for this complementary angles, the range is going to remain the same. So we know that range is equal to u square sine 2 theta by g, and I've found this function for range of 90 minus theta, and again I know that 180 minus 2 theta is nothing but sine of 180 minus 2 theta is nothing but sine 2 theta. So the range of 90 minus theta is equal to range of theta, which means for these two complementary angles or for the complementary angles, the range is going to be same. But guys, this also tells you something. You know what? As and when this object is in projectile motion, you see that at 15 degrees and at 75 degrees, the range is same. And at 30 degrees and at 60 degrees, the range is same. Doesn't it tell you something? At some point, it has already reached that maximum range for that same velocity. And what is that value? That value is nothing but 45 degrees. If you work out either through, like a differential mathematics, you'll find out that the maximum range is 45 degrees, or you can simply do it intuitively, where 90 minus theta is equal to theta, which is nothing but 2 theta is equal to 90 degrees. That is, theta is equal to 45 degrees. At 45 degrees, this object will have maximum range. And the range for complementary angles are equal, which means range of 15 degrees is equal to range of 75 degrees, and the range of 60 degrees is equal to the range of 30 degrees. And similarly, you work out for any complementary angles, you will find out the range is same. And now let's talk about the ratio of range and H max. It's a very interesting concept, guys. When you work around this range by H max, that is, you substitute the equation for range and H max. So range comes on the numerator, which is nothing but u square sine 2 theta by g. And on the denominator comes the H max, which is nothing but u square sine square theta by 2g. This g on the numerator and the g on the denominator is going to get cancelled. And similarly, u square is going to get cancelled. Which means the ratio of range and H max is independent of the gravity and initial velocity. Even if you move to moon, if you project it, you will find that there is a correlation between range and H max. Guys, this is very important. The ratio of range and H max is independent of gravity or gravitational acceleration and initial velocity. And you will find that you do a little bit of trigonometry, that is, you expand sine 2 theta, which is nothing but 2 sine theta cos theta, and on the denominator there is a sine square theta. You cancel this sine theta with sine theta, which is nothing but cos theta by sine theta, which is nothing but 1 by tan theta. So R by H max is equal to 4 by tan theta. There was a 2 over here, and this 2 from the denominator goes to the numerator, which is going to be 4. So it's 4 by tan theta. So guys, doesn't it tell you something? Doesn't it talk about something like, slope proportionality thing, or that equation that we derived earlier, the equation of the projectile trajectory that we derived earlier. So H max by range is proportional to tan theta, which is proportional to theta. So it's just a slope proportionality thing, guys. Remember this thing. H max by range for a projectile motion is proportional to tan theta or theta, and it is independent of initial projectile velocity and gravity. Okay, guys. There are some limitations of projectile motion. Projectile motion is assumed to be only under the action of gravity, which might be not true in the real cases. You deliver some sort of force, but in an ideal projectile motion, it is only under the action of gravity. And projectile motion is assumed to be free of air resistance. That means the projectile motion, in a projectile motion, we assume that there is no air viscosity drag on this object moving in projectile motion. And the next thing is, projectile motion is assumed to be free of spin. Which means if you're projecting a ball or some object, you're assuming that it is not spinning. There's no rotational motion in it. Okay. And there are also other limitations. The other one is, it says that in a projectile motion, it is assumed that the earth is flat, which is not true. And again, it is assumed that there is no rotational motion of earth. And it also assumes that in a projectile motion, while you are calculating this projectile motion, you assume that, there is no energy loss and the energy is preserved. So you assume the following things while doing projectile motion, which is basically the limitations of projectile motion theory. One, the object in projectile motion is only influenced by gravity. There is no other external force on it. And you assume that there is no air viscosity drag. And the object in projectile motion is assumed to be free of spin. You assume the thing is like earth is flat, the earth is not rotating. But these are like negligible effects. And in the projectile motion, you also assume that the energy is preserved. So now we'll solve some MCQs or some short problems on projectile motion, guys. And these are some tricky problems and I'll tell you how to solve them very easily. So you see the first question, this is the first question, and it says that two bodies of same mass m are projected at different angles 55 and 35 degrees but with the same initial velocity u. Then which of the following is true? So they are talking about range and maximum height in every problem. You know that this object is projected at 55 and 35 degrees angle but with the same velocity u. So that means these are like complementary angles, right? So both these objects or both these bodies are going to have same range. But what about the height? Height is not going to be the same. Okay? So it's basically going to be the option, I guess it's the option, they'll have the same range but different maximum height, the option B. So that's what we did over here. We solved it conceptually. Now it's talking about, H max is like proportional to sine square theta, and the maximum height cannot be same because H max is proportional to sine square theta. That means the body projected at 55 degrees angle is going to have more height. It's logical, right? I'm going to project an angle at 55 degrees and I'm going to project an angle at 35 degrees. Of course, they are going to have different heights, and the object projected at a greater angle has a greater height, and it also travels longer. So the next question talks about there are two objects of different masses m1 and m2 in projectile motion with different initial velocity u1 and u2, where u2 is greater than u1. That is, the velocity of object B is greater than that of object A. Then which of the following is true? Guys, are you missing something in this? Yes, that's theta. The question does not talk about theta. It talks about u1 and u2 not very quantitatively. It does not give the numeric values of u2 and u1. Can you find out something with that? Probably not. So the time of flight and maximum height and range is the concern in this problem, but you do not know anything about it. Since you do not quantitatively know the initial velocity of object A and B, and you do not know quantitatively about the angles. The angle is not mentioned, so you cannot determine the time of flight, maximum height and range. So let's come to the third problem. The third problem says that there are two objects A and B of different masses m1 and m2, where m1 is greater than m2. That is, mass of object A is greater than that of B, and are launched at an angle 45 degrees with different initial velocity u1 and u2, where the velocity of object B is greater than that of A. So u2 is greater than u1 means object B has a greater velocity than that of, object B has a greater velocity than that of A, but the mass of A is greater than that of B. Guys, this is a way to confuse you. You know what? This is irrelevant, guys. This does not matter. Masses don't matter, right? At least when it is about range, time of flight and H max, that's what we are concerned about in this problem. And you know that both are launched at 45 degrees angle. It's a maximum range problem. So both of them are going to have, like the maximum range that they can go for further. And now we know that velocity of u2, that is object B, that is u2 is greater than u1. Velocity of object B is greater than that of object A. So velocity of B is greater than that of object A means object A is going to travel farther in X and farther in Y, and also it is going to travel longer. I mean, it is going to take more time to complete this projectile motion. The time of flight of B is going to be greater than that of A. The range of B is going to be greater than that of A, and also the maximum height attained by the object B is going to be greater than that of A. So the masses were just given to confuse you, and you will find a lot of problems in IIT JEE problem set, or even in the exams, that they are giving these to just confuse you. You must ignore these points and quickly skim through the problem to understand what is the essence of the problem and what is really related to this problem. So that's what we did in the solution as well. We did it like more on a numeric way, where I'm calculating the range, where I'm calculating the Hmax, and I'm still getting the same result, where I'm saying that the time of flight of B is greater than that of A, the range of B is greater than that of A, and the maximum height attained by that B is greater than that of A. Now let's come to the next problem. This says that two objects A and B of same mass m but with same initial velocities are in projectile motion. That means these two objects have same mass and they have same initial velocity, but they have different r by Hmax. And the problem says that it is found that A has an r by Hmax, that is range by Hmax ratio, or the ratio of range and Hmax is greater than that of B. So A has a value of r by Hmax greater than that of B. So now we will work with this, proportionality thing, slope proportionality thing. So this problem is concerned about angle of launch. You see, angle of launch, angle of launch, angle of launch. So now the thing is, we can conclude something just conceptually or intuitively, that r by Hmax talks about slope, or the angle at which these objects are projected. Since it's the other way around, that is that inverse of r by Hmax is proportional to theta or tan theta, B is projected at a larger angle. Okay. The ratio of range and Hmax for A is greater, that means B is projected at a larger angle. The tan theta for B is greater than that of tan theta for A. So the angle of launch for B is more than that of A. But what about the range? We don't know. If they are complementary angles, what about the range? It can be the same. So it might be that they may have same range but different angle of launch, that's for sure. But we definitely know that B has been launched at a greater angle than that of A, since A has a larger value of r by Hmax than that of B. So yeah, we did it using this proportionality thing, and B has been launched at a greater and larger angle than that of A, and we cannot talk about the range. They can be also same. If they are complementary angles, it might be same because they also have same velocity. Okay guys, let's go to the next problem. It's an interesting one, guys. So it says that two objects A and B of same masses, nothing confusing, with same initial velocity, again nothing confusing, but are launched at different angles, that is 60 degrees and 30 degrees. So object A is launched at 60 degrees, object B is launched at 30 degrees, and they have the same initial velocity. It's complementary angles, right? See, 60 degrees and 30 degrees are complementary angles. But you know what? They are going to have the same range. But B is projected at a lesser angle. A is projected at an angle 60 degrees, which is more than that of B, which is 30 degrees. Which means A has gone to attain a longer height, longer Hmax. It has traveled more along the y-axis. So I think it's talking about, A flew root 3 times greater than that of B. B flew root 3 times longer than that of A flew. But the problem is actually about time of flight. So now I know that it has traveled more along y-axis. The time of flight for A is also more. But guys, what now? I need to quantitatively define it, right? So I know that it's basically, the time of flight is proportional to sine theta. It's nothing but 2u sine theta by g. And sine theta of 60 degrees is root 3 by 2, and sine theta of 30 degrees is 1 by 2. And when we divide this, we know that object A has traveled root 3 times more than that of B. That is, object A has remained in the air root 3 times more time than that of B. So it is basically saying that object A flew root 3 times longer than that of B. Actually, there's another confusing option over here which you have to neglect. And you have to ignore, and you should definitely quantitatively find out that object A flew root 3 times longer than that of B. And now let's have a look at a little advanced problem in projectile motion. It's a very interesting problem. You can visualize this problem. So this problem is saying an airplane is moving with a horizontal velocity v at a height h above a level plane. If the ball is thrown by a man at an instant from the level plane when the plane is vertically above the man, then what should be the minimum initial velocity of the ball in order for a person on the plane to catch the ball? So let's first understand this problem, guys. So there is a plane. Let's assume you're in this plane, or you're sitting on this plane, and I am on this level plane. And you know what? You're flying at a height h above me, and you're traveling only with a horizontal velocity v. So I know that you're at a height h. What I'm planning to do is I'm planning to throw a ball, and I want to make sure that I throw a ball in such a way that you're able to catch that ball. You are always moving with respect to time with an horizontal velocity v. But right now I have a ball, I'm in a stationary position. I can only give this object or this ball an initial momentum or this initial velocity to make sure that this object reaches you. So let's now first visualize it pictorially. So what is the thing? So this is an object. Okay, this is me holding the ball, and this is you in this airplane, and the flight is flying higher above me at an height h. It's above me at an height h, and it is moving with an initial velocity, a constant horizontal velocity v. And now I need to project it at some angle theta and at an initial velocity u. Guys, notice a thing careful in this problem. We are not talking about actually theta, we are talking about the minimum initial velocity. So you must have got a clue from this that we may be able to eliminate this theta. Okay? So what do we do now? We know something. So the plane is traveling at velocity v, you are traveling at velocity v. So I need to make sure that I give it a horizontal velocity such that it matches your plane velocity. That is your velocity in that plane. And the next thing is, I should make sure that it reaches that h max, that height h as the h max. I need to make sure I give it enough velocity along y such that it overcomes this gravitational acceleration and reaches that point h along y axis. So now what we are going to do? We are going to write down those two conditions. That is, the first condition would be that ball's horizontal velocity should be equal to the plane's velocity. That is saying that u cos theta. So I'm resolving this component along, x-axis, which is nothing but u cos theta is equal to v, which is the velocity of the plane along x-axis. And the next condition is I need to make sure that the ball reaches you. So first of all, I need to make sure that I have to give it enough velocity such that it gets until that height where you're sitting on the plane. So I must make sure that ball has the vertical velocity such that it should be good enough to reach the height of the plane, which is nothing but h in this case. And what I'll do, I'll make use of this h max equation, which says that h max is equal to u square sine square theta by 2g. So h max is equal to u square sine square theta by 2g. I'll substitute that h max is equal to h, that is the minimum height that I need. So I need to only give it that minimum velocity. So that is the minimum height that I need. And I'll find out that u sine theta, that is the velocity along y-axis, should be greater than or equal to under root 2gh. Okay guys, now we will walk through the clue. Clue says that theta is not required to solve this problem, or we should eliminate this theta to solve this problem. And what we are going to do now, we are going to basically take advantage of this trigonometry thing where it says sine square theta plus cos square theta is equal to 1. I'm going to basically add u square cos square theta and u square sine square theta. That is what we have done over here, right? And when you take this u square as common, u sine square theta plus cos square theta would become 1. So it's basically u square into 1, isn't it? And it should be greater than v square, which is the velocity of the plane. The velocity of the plane you're sitting in. Plus of under root of 2gh whole square, where h is the height at above which the plane is flying. And which is nothing but 2gh. So u square should be greater than or equal to v square plus 2gh. And u should be greater than or equal to under root of v square plus 2gh. So what should be the value of u? The minimum velocity is what we are concerned about. So the minimum velocity should be equal to under root of v square plus 2gh. So we should give it an, like a minimum initial velocity of under root v square plus 2gh to make sure that the ball I throw at you reaches you on the plane and you are able to catch it. Alright guys, now we will look at a special case of projectile motion, which is nothing but solving for a projectile motion from a height. So in this case, what I've done is I've only given this velocity along x-axis and I'm standing at a building that is at an height h from the ground, and still I'm making a projectile motion. This body is moving in a curvilinear path under the action of gravity. So now we are not concerned about the maximum height, because we already know that we are standing at height h, which is the maximum height. There is, we are not giving it any y-axis momentum. So it is not going to go any height beyond that h. But we can find out couple of things, this two kinematic properties. One is range and the other one is going to be the time of flight. So how do you solve for this? It's really, really very easy, guys. It's even easier than that ideal projectile motion case. So what did you do? You know one thing, that the height, that the y-axis, displacement is going to be height of the building, which is nothing but h, and sy is equal to uyt minus half gt square. That second Newton's equation of motion is where you're going to substitute it. And you know that you haven't given any initial velocity along y-axis, so this term is 0. So this term uyt is 0, and all you have is minus half gt square. And guys, you need to take care of this sign convention. This will be like minus h, right? This won't be h. This would be like minus h, because it is in the minus y direction. So I would substitute sy is equal to minus h and equate it to minus half gt square. I would take this g over, to the denominator. It will come on the denominator. On the other side, I would take it to the other side. It will come on the denominator. And this half would go up over here and become 2. So the time of flight would be, in this case, under root of 2h by g, where h is the height of the building, or the height of, the height on which I'm standing or you're standing, and you throw this ball only with, velocity along x-axis, then the time of flight is going to be under root of 2h by g. So what is going to be the range? The range is the easiest thing that you can calculate. So what is going to be the range? Range is going to be nothing but velocity along x-axis into the time of flight. So this is what you are going to do each and every time when you come across the range. What you have to do is, you have to multiply this velocity along x-axis into the time of flight. So that's what we have done. So what we have done is, we have taken this Newton's equation of motion, again this second Newton's equation of motion, which is nothing but Sx is equal to ux into t, and we know the time of flight. We have calculated it earlier. We are multiplying it by u. Since in this case u is the velocity that we gave, along x-axis. There is no velocity along y-axis, and we are not even concerned about it when you are calculating the range. So range is nothing but u into under root of 2h by g. That is nothing but ux into time of flight. Alright guys, this is another special case of projectile motion. So now what we are going to do is, we are going to project this object from an height edge or from a building that is at an height edge in an ideal projectile motion path, just in the regular projectile motion path where you give momentum both along x and y axis, and in this case you're projecting it at a certain angle theta. Things are only tough as long as you don't know them, but you now know everything, guys. Like you have learned everything about range, maximum height and time of flight, and you can solve this very easily. And we'll do the usual stuffs to solve this problem, It's not really a complicated thing. It's a very, very easy thing, guys. As usual, we would write down this initial conditions along x-axis and y-axis. Now the thing is, when I'm talking about time of flight, this is this entire time. This entire time that where this object, completes this level surface projectile motion, and then it has to go in this negative y direction and come down. So now what I'm going to do is, I'm going to, calculate this time dividing it into two parts. The first part would be this part where it completes this level plane projectile motion, and the second part would be from the height edge until the point where it reaches the ground. So we already know the time of flight for this. We have already calculated this, and I'm assuming this total time of flight is t, and I'm taking that t1 is the time it takes to complete this first part of the projectile motion, that is the level plane projectile motion. Now we need to calculate t minus t1, where t is the total time of flight. So how do we do this? So now what we do is, we take these two Newton's equation of motion. One is going to be Vy square is equal to Uy square minus 2GSy. From this we will get Vy final, that is the final velocity of this object as and when it reaches the ground. And then we are going to make use of this Vy final when it reaches the ground to find out the time that it has taken to get this velocity. V is equal to u plus at, that's what we have to do, but along y-axis. It's really that simple. So now what we are going to do is, we are going to first find out Vy square, the value of Vy final when it reaches the ground, and we are only calculating it for the second part of the projectile motion, that is once it reaches that level plane until the ground. So Vy final square is equal to u square sine square theta minus 2g minus h. Y minus h, again because this is negative y direction, so you would substitute it as minus h, and you would find out that Vy final whole square is equal to u square sine square theta plus 2gh, which says that Vy final is equal to plus or minus under root of u square sine square theta plus 2gh. So remember guys, we have substituted this minus h for a projectile motion from a height, because we are always considering that we are projecting it from the origin, or we are standing at a neutral position. And guys, what would be the direction of Vy final when it reaches the ground? The gravity has started accelerating it in the negative y direction. So Vy final would be minus of under root of u square sine square theta plus 2gh. So we would be a little bit confused when you are taking this root, but you already know intuitively it's going to be minus. So Vy final would be minus. Now we will make use of this in this equation, where we'll be applying it to V is equal to u plus at, the first Newton's equation of motion to calculate the time of flight. So now guys, we already know Vy final, and now what we are going to do is, we know the final velocity when it reaches the ground, and we know the initial velocity in this case is the initial velocity from this point, from the point where it has to go from the level plane until the ground. So basically it is, we are now calculating the time of flight from this position to this position, and we spoke this earlier, right? So the magnitude of velocity along y-axis at this point, that is a level plane point. Again, I'm drawing this line to make sure it's a level plane, and at this point is going to be the same. The magnitude of velocity is going to be the same, but the velocity is in the opposite direction. So it's going to be minus u sine theta. Okay guys, so what I would do is I would substitute this uy as minus u sine theta, and we already know that it's minus gt because gravity is in the negative y direction. We also know that vy final is in the negative direction. We already calculated, and we saw that. Now what would you do? And another thing guys, you can also intuitively do this problem. That is, you basically move these things around a little bit. That is like, you take this u sine theta on the other side, we have to calculate the t. That is what we have done in this problem. You have basically moved this, minus u sine theta to the other side, and you find that gt is equal to minus u sine theta. Because see, I have cancelled all these negative signs and moved u sine theta to the other side. So it's going to be minus u sine theta plus of under root of u square sine square theta plus 2g, which is nothing but vy final when it reaches the ground. And then we know the t minus t1. We also right now know the time for the second part of the projectile motion, that is from the level plane to the ground. And now that is nothing but t minus t1 is equal to t is equal to minus u sine theta plus under root u square sine square theta plus 2gh, and this whole value is divided by gravity. You have basically taken the gravity to the denominator. And I now know the t minus t1. I'm going to add it to the t1 to find out the total time of flight t. So that's what we have done over here. We have added both of these values. T is equal to t minus t1 plus t1, that is nothing but 2u sine theta by g plus of minus u sine theta plus vy final by g. And this is minus and this is plus 2u sine theta. So the total time of flight is nothing but u sine theta plus of under root u square sine square theta plus 2gh, which is nothing but vy final, the velocity when the object finally reaches the ground, by g. So this is the total time of flight. So let me ask you, so what would be the range? Range would be really simple, right? Again, it is going to be time of flight into u cos theta. That is all is range. That is all is the displacement traversed by this object along x-axis. What about maximum height? Maximum height, you're going to add this height of the building and this height of the level plane motion. You're going to add them both. That is it. Again, you're going to divide it into two parts and find it out. So now I'm saying that this height of this maximum height of this level plane motion is h max minus h, where h max is the total maximum height and h max minus h is nothing but uy squared by 2g. It is basically that point where you lose all the velocity along y direction. You make use of v square is equal to u square plus 2as along x-axis. And you would find out that h max minus h, that is for that level plane projectile motion, it is nothing but h max minus h is equal to uy squared by 2g, which is equal to u squared sine square theta by 2g. And we would have to simply take this h on the other side. Guys, it's really simple. Always break this complicated problems into two parts. One is h max minus h, the other one is h. Similarly, for time of flight, what would we do? We took this level plane motion and then again we calculated from this level plane motion until the point where this object reaches the ground. It became really simple. And range, guys, we discussed this. Range is going to be really simple. You have this time of flight, you have the velocity along x direction. You're going to basically multiply that Range is the simplest thing you can calculate in projectile motion. And in fact, even time of flight is very simple and maximum height is very simple. You've seen all of this, guys. It's really, really easy. So we'll have a look at one of these things. In a projectile motion, we are assuming that there is no viscosity. But what would happen to an object which, ideally should travel like this without any air resistance? But let's say we have an air resistance. Then what would happen? The object would not be able to travel, farther along X and Y axis. The reason being, there is a drag, viscosity is dragging this object, is decelerating this object, both along X and Y axis. So this object would travel lesser height and lesser range compared to the same object without air viscosity or air resistance. So guys, in the next lecture, we'll look at how to solve this projectile motion on an inclined plane. I guess you must have understood everything. If you did not understand, please comment below. Please do comment below. I would like to know what you didn't understand and what you would really love in this lecture. And guys, one more thing, download our app, go to Play Store, or you can go to this app store if you have an iPhone and get this app, and you can attend our special classes which are also free of cost, and subscribe to our JEE English channel. And we are going to deliver best-in-class contents with IITians and people from premium universities, guys. All of these people or educators who are teaching on this channel are clear IIT and they are very recognized in this field. And guys, one more thing, if you are interested in getting subscription, make use of my code. You'll get a 10% discount. And the best thing about this, Unacademy subscription is you get test series, guys. I really recommend that you attend this test series, you get this structured learning. If you're early, like in 10th class and all, get this, structured learning. It helps you a lot. Your concepts will become more and more clearer with this structured learning. And more importantly, guys, we are best-in-class educators delivering lectures on this Unacademy subscription channel or the subscription platform. Guys, and yes, you can make use of my coupon to get a 10% discount, which is nothing but Murli Live. Guys, stay tuned to this JEE English channel and stay safe. Let's see you in this next lecture. Alright guys, take care. Thank you. Bye-bye.